All right, physics friends, here we are today, and we're going to do an example of a horizontal launch problem. So what I have here is I have a ball up here on this 20-meter high cliff, and I'm going to kick it at a speed of 15 meters per second, and I want to know if I can hit this boat, which is 20 meters from the base of my cliff. Okay? So let's look at what's going on here first. So a couple things that I know. I know that this object is going to move forward in the x direction because of inertia, and it's going to fall down towards the water level because gravity is going to accelerate it downwards. Which means that the path that this ball is going to take as it leaves the cliff is parabolic in shape. Something similar to this. The question is am I going to hit the boat? Okay. And so there's a couple things that I can do here. The first thing I should do before I get all worked up and worried about whether or not I know how to do this is I should make myself a two-column given chart and fill it in with all the information I know about my situation. So my two-column given chart, just a T-chart with two columns in it. The first column is your list of variables, V, V initial or V naught, A, T, S, and S naught being your final position and your initial position. Then this first column is for your X direction, and the second column is for your Y direction. And remember that they have to stay separate because the X direction has its own acceleration and so does the Y direction. Okay? And speaking on that, we know what the acceleration in the X direction is. There is none. There's no outside force acting on the ball in order to move it in the X direction. And so I can put in the X column next to the acceleration 0 meters per second squared, because there is none. But in the Y direction, it's the acceleration due to gravity, and that's always negative 9.8 meters per second squared. Okay, so that's true near the surface of the Earth. What else do I know about this problem? Well, I know that the initial velocity is 15 meters per second. That 15 meters per second is directed completely in the X direction, or the horizontal motion. And so that means the initial velocity in the X direction is 15 meters per second. Is there any velocity initially in the Y direction? Well, no, because I kick it horizontally. So all the initial velocity is in the X direction, and there is 0 initial velocity in the Y direction. Okay. I don't know anything about the final velocities. These would be the velocity that it hits the boat with. Okay. We'll solve for that at the end if we actually hit the boat. Okay. Other things that I know that the edge of the cliff here in the X direction, or my initial position in the X direction, I'm going to say that that's 0. And I want to know how far out in the X direction I'm going. So I'm going to put a question mark there because that's my ultimate goal. And then I'm going to compare it with 20 and see if I hit the boat. I also have some information about how far the ball falls in the Y direction. I know it falls through 20 meters. I like to set my final position, the level of the water, as 0, because then my initial position is a positive 20 meters above. You can set the initial position of the ball 0 here at the top, but then your final position has to be a negative 20 because the 20 meters is below 0. Okay? So I'm going to say my final Y position is 0, and then I start 20 meters above. Okay? The key to solving two-dimensional projectile problems is to find the time, because time is the same in both the X and the Y axis. They're equal. It's the only variable that will always be the same between the two. Okay. So let's start out by finding the time. Okay. I have three kinematic equations to work with. I have V equals V naught plus AT. I have S is equal to S naught plus V0t plus 1/2 AT squared. And I have v squared equals v naught squared plus 2a delta s. And I need to find the time. Well, the question is which column do I have enough information in? You have to have 4 variables in a column in order to solve for something. So I only have 3 variables in the x column, so I can't use that column. But I do have 4 variables in the y column. And I'm looking for time, and so I need to either use the first equation or the second equation. I do not have final velocity, so I'm going to use the s equals s naught in the y direction. So in the y direction, I'm going to use s is equal to s naught plus v0t plus 1/2 a t squared. And then I'm going to plug in my variables. S is 0, s naught is 20, plus 0 times t, plus 1/2 negative 9.8 times t squared. Okay. 0 times t is 0, so that goes away. And I'm left with 0 is equal to 20 plus 1/2 negative 9.8 t squared. Okay. Subtract 20. And then I'm left with 1/2 times negative 9.8 is negative 4.9 t squared. Divide by negative 4.9. And calculator. Should always have a calculator handy. Let's see, we've got 20 divided by 4.9 gives me t squared is equal to 4.08. So then you square root. And you're ended up with t is equal to 2.02 seconds. And what's nice about that is I can put that in both my x and y column here. And now I have enough information in my x direction to solve for final position. Okay? So I'm actually going to come back and I'm going to use this same equation, s is equal to s naught plus v0t plus 1/2 at squared. But in this case, I'm going to do it in the x direction. So I have s is equal to s naught plus v0t plus 1/2 at squared. And the nice thing about this is the acceleration in the x direction is 0. And so this whole piece goes away because 0 times anything is 0. And my initial velocity my initial position, in the x direction is also 0. So my equation ends up being s is equal to v0 times t. So s is going to be equal to 15 times the time, 2.02 seconds, which leaves me with a distance of 30.3 meters. And 30.3 meters, well, that's bigger than 20 meters, so the boat is safe. I don't hit the boat. I land somewhere out here. Okay, so my actual projectile path is something like this. Okay. Cool, that's awesome. That's a very common question. Where does your projectile land, or do you hit something? Another common question is, what is the final velocity when the ball hits the ground, or when the ball hits the water, or whatever it happens to be? And you might think it's 0, but you're wrong. You are correct in saying that the ground or the water or whatever brings the object to rest, but it has to hit the ground moving. Okay? And so in that case, if this is my ball, I know that it has a final x velocity, or vx, and because the acceleration in the x direction is 0, the final velocity in the x direction is the same as the initial velocity in the x direction. So vx in this case is 15 meters per second. Okay? But then there's some y velocity, and it's going to be pointed down because the ball is falling down. So I don't know what that is. And I can find that using my y column. The easiest equation to find this value right here is the first one. And so I end up with v is equal to v naught plus at, and then I use my y column data, and I get v is equal to 0 plus negative 9.8 times 2.02 seconds. So 9.8 times 2.02, that is 19.8. So that would be v is equal to negative 19.8 meters per second. But that's not the overall final velocity. The overall final velocity is this orange arrow that I'm drawing. That final velocity I can find by our good friend Pythagorean theorem, because this is a right triangle, and a squared plus b squared equals c squared. So a squared plus b squared equals c squared, and that would give me 15 squared plus negative 19.8 squared is equal to c squared. Okay. So 15 squared, that's 225, plus 19.8 squared, 392 is equal to c squared. So 225 plus 392, and then that's 617, and that's c squared, so then take the square root. And I get 24.8 meters per second. That equals the overall final velocity. There is another small part to this where you might have to find the angle that the ball lands at. And so that would be this angle here, or that angle theta. And in order to find that, you would have to use trig, or trigonometry. And in this case, I would use the tangent of theta, because that equals the opposite side of the angle over the adjacent side. Okay? Or in physics terms, that would equal Vy divided by Vx. Okay? And if I'm looking for theta, that means I have to divide by tangent. And if I divide by tangent, that's saying 1 over tangent, or tangent to the negative 1. So theta is equal to tangent to the negative 1 of the quantity Vy over Vx. Okay? And so in your calculator, that function can be found right above the tangent function in blue, tangent to the negative 1. So I go tangent to the negative 1, and then I would put my values for Vy and Vx in, and Vy is negative 19.8 divided by 15, and that gives me a, oops, I must be in radians. Make sure you're not in radians mode. Yep, go to degrees, and then try that again. And I'm left with 52.8 degrees below the x-axis. So your final velocity is 24.8 meters per second at 52.8 degrees below x-axis. And that's how you could solve for final velocity, as well as how far from the base of the cliff a projectile will land.